In this video here, we're going to look at calculating the average rate of change in multiple different contexts. So the first average rate of change, or the gradient, that we're calculating here is we're going to use a formula and we're given a domain or an interval. So right now we do have the x values, but what we don't have are the y values. So we need to find them out. We're going to substitute in x equals 1 first to find out our y value. And run this calculation so you can evaluate what our y value is. So there you go, there's our first, essentially our first coordinates. So you can rewrite this as a coordinate form if you prefer, or you can rewrite it as f of -1 equals 6. This is in function notation here. It's good to know both because that helps you become more flexible when you see the formats in different styles. Okay, so in this second one here, I made a little mistake. We want to substitute x equals 2 and find out what the y value is. Now we've got both of our coordinates. We can calculate the gradient or the average rate of change. So average rate of change over this interval here is basically y2 minus y1 over x2 minus x1. So the way that I like to do it is I like to set this up. I can write out the formula as well. I still like to write out y2 minus y1 over x2 minus x1, but just have a watch of how I set this up first. I set up the vinculum, which is the division line, and the two negatives at the top and the bottom in the numerator and the denominator. Then all I need to do is fill in y2, y1, x2, x1. Once that's done, you can essentially substitute in your values. So again, setting up the framework first, because this is going to help you avoid confusion with any sort of double negatives like this -1 here. Students often make a mistake right here, which is very common to make a mistake there. So our average rate of change is equal to 1. The next example that we're going to do is, again, we're going to find the average rate of change with y respect to x. So our rate of change of y changing in relation or with respect to our x value, we're going to find from point A to point B. We can see here in this question, we're given a graph instead of a formula this time. And that's absolutely fine because we can just use our coordinates. Again, setting up your formula. Then making the substitution. We've got one more example here, and it's giving us this structure here in the sense that it's given us an equation or a formula to work with, and it's talking about the position or the change in position. relative to its origin, or where it starts, and the amount of time that it begins to move in. So just focus on this here. T has to be greater than 0. So here it says find the average rate of change of the position of the object in the first 2 seconds. Then we want to find it in the next 2 seconds. So it's important for us to find out or define what the timestamps are for our first 2 seconds. So essentially when t is equal to 0 until t is equal to 2. This is what defines the idea of the first 2 seconds. And again, we are finding the average rate of change. Okay, so essentially we are calculating the gradient, m. We need to find out our y values. That's what we're going to do. I'm just going to show a quick substitution here before I write out the y value. Okay, now that we've got our 2 coordinates per se, or the 2 timestamps, or when the position of S is at t equals 0 and t equals 2, we can find our average rate of change. Set up the infrastructure first. y2 is 8, y1 is 0, x2 is 2, x1 is 0. Now, it's not okay in this particular context if we just leave our answer as 4. We need to look at the context of the situation here, which is alluding to the idea that we are talking about meters and seconds. Because we did our gradient, which is a rate of change, we want to show how quickly the meters changes with respect to our seconds. So what does this 4 here actually mean? It shows that we are changing 4 meters for every second, or 4 meters per second. It's the exact same reason why we have our y at the top, which is our s in meters, and we have our x values at the bottom, which is t in seconds. So making sure you write this idea of a rate at the bottom. If there's some sort of story attached to it. Okay. And last but not least, we're going to do it in the next 2 seconds. So if we're talking about our next 2 seconds, we're talking from t equals 2 up until t is equal to 4. Now let's see if these numbers will stay the same or if it will change. So for t equals 2, we've already made that calculation. We did find out that it was 8 based off of our previous question. When t is equal to 4, we need to do this as a new calculation here. Oops. (32 plus 16, 48). Now that we have our 2 timestamps and their associated s values, or essentially our coordinates, we can set up our calculation. Y2 is 48, Y1 is 8, X2 is 4, X1 is 2. So now we are changing at a rate of 20 meters per second. So it started off in the first 2 seconds, it was quite slow in terms of its position changing, but then between 2 seconds to 4 seconds, its average rate of change, or how quickly it changed, increased to 40 meters per second, which is significantly faster. So across these three contexts here, these three examples, and pause, rewind, and rewatch if you'd like to revise. Thanks for watching.